This is the alternative assignment to the quiz is. I know not everybody has internet access, so if you would rather do this sheet, this is the option, but you do not have to do this if you're going to do the Pythagorean quiz is assignment. Sorry, the Pythagorean theorem quiz is assignment. So again, this is only for people who are doing this as an option instead of the quiz is. Okay, so here's the situation. Is Horace Hansen is a catcher for the Humboldt Bees baseball team. Sneaky Sally Smith, star of the Canfield Cats, is on first base. Sally is known for stealing bases, so Horace is keeping an eye on her. The pitcher throws a fastball and the batter swings and misses. Horace catches the pitch, and out of the corner of his eye, he sees Sally take off for second base. So, we're working at a little bit of sports here. Now, you don't have to have a real deep understanding of the game of baseball to get this problem. In baseball, it's called stealing a base. If you run when the ball is not hit, like if the pitcher pitches it, you are allowed to run and try to get to the next base. That's called stealing. So Horace is at home plate. Sally is going to be at first base. So I'm going to go ahead and label that right here. That's where old Sneaky Sally is. And then Horace is going to be down here at home plate. So question number 1 says, how far must Horace throw the baseball to get Sally out at second base? So we're trying to find the distance between home plate and second base. That's going to be this distance right here. Okay, now if you notice in the corners, every baseline turns at a 90-degree angle. So it's a 90-degree angle in each corner. So what you have here is you have a right triangle with legs of 90 and 90. So I'm going to label this leg A, this leg B, and then this distance that we're trying to find here, that would be C. So we can set this up as a right triangle problem. Now I'm not going to solve it for you because then it would just be me doing the assignment instead of you, but we've been working with right triangles the past couple of days. A squared plus B squared equals C squared. So if we want to set this up as a problem to solve, is it would be 90 squared plus 90 squared equals C squared. And then that's when you want to find them. Sorry, I had a little spot in the table there. So that's where you would want to solve for C. Remember, square A, square B, add those together, find the square root. Now let's look at the second problem. It says the shortstop is standing on the baseline halfway between second base and third base. How far is the shortstop from Horace? Okay, so if you played baseball at all or watched a baseball game, shortstop is a very important position, and they stand halfway between second base and third base. So it's asking how far the shortstop is from Horace. So it's going to be halfway here. I'm going to make a little mark there. And then from home plate, it's going to be this distance here. Now you'll notice we have another right triangle where here we have a leg of 90, and then here we're going to have a leg of 45. Now how did I get that? If the shortstop is halfway between third base and second base, that distance is 90 feet, because in baseball it's 90 feet between each of the bases. So it makes a right triangle of 45, which is going to be A, 90, which is going to be B, and then we're trying to find another hypotenuse. So if we want to set that up, as we would set that up as, I'm going to write this out here, is it would be 45 squared plus 90 squared equals C squared, and then we would solve that the same way we would any other Pythagorean theorem problem. Okay, and then the last question says the pitcher's mound is 60 feet and 6 inches from home plate. Use this information and your answer to question A to find the distance from the pitcher's mound to each base. So the pitcher is going to be 60 feet and 6 inches. That's also 60 and a half feet. So we're going to try to find the distance he is from each base. Now I'll tell you that a baseball diamond makes this square. So if we find the distance to one base, it might be safe to assume, actually I tell you what, scratch that, because we have 4 different right triangles, and so I don't know if we can assume that he's the same distance from each. So this here would be 60.5, okay, and then our right angle would be here, and then this is the distance that we're actually trying to find. Now that's going to have to be one of our legs, okay? So when we set that up is we're going to do a squared. I called that one b, so we're going to do a squared plus b squared equals c squared. I know I had an a there earlier, but that's now going to be c. So when we set this up, it's going to be 60.5 squared plus b squared equals 90 squared. So when we set this problem up, it would be 60.5 squared plus b squared equals 90 squared. Because we have legs of our triangle are 60.5, we have an unknown leg, and then this distance is going to be 90 feet. Okay, so we just set this up. Now remember, we have to square each of these and then use subtraction to get b by itself, because if you remember on NTI day 4 and 5, we were looking at how to find missing legs. So that means you're going to have to square both of these, subtract this value from both sides, and to solve for b. So I'm still available. Any questions, let me know. Keep in mind there's not going to be an NTI assignment for this Friday. This is Thursday's assignment because we did not have a regular school day scheduled for Friday. So I'm available. Hit me up. If you have any questions, you can email me, remind, whatever would be best, and I'll get back with you as soon as I can. All right, stay well and have a good one. Bye.